So we're going to talk about prime numbers here. Now you probably already know what a prime number is, but we need to be quite exact about our definition of it. And this is a pretty good definition of it. A prime number has exactly two factors. Now you might have another idea kicking around in your head. A prime number only has two factors, one and itself. But that's a small problem because there is a prime number that doesn't follow that rule. And that's the number 1. The number 1 is not prime. Why? Because it doesn't have two factors. It only has one factor. 1 times 1 equals 1. So if you were using a different definition, say a prime number only has factors of 1 in itself, then 1 would be prime. But that's not our definition. Our definition is a number that has exactly two factors. Now for most numbers, that's 1 in itself. 13 is prime because its only factors are 1 and itself. But exactly two factors is the way we should think about it. So one thing you want to be able to do is test for primeness, to be able to figure out whether a number is prime or not. And it doesn't take as much work as you might think. Now, to do this, I'm going to do it first with a number that I know isn't prime. So I've got the number 100 here. Now, everyone knows that 100 isn't prime. I'm sure you can think of some factors. When we test for primes, we have to test systematically. Alright, so I need to ask myself, well, 100, what's that equal to? Well, I've got the prime. I've got 1 times 100. And if that's all it was equal to, then that would be prime. But I have something else. What about the number 2? 2 times 50. Okay, so I already know it's not prime. But I'm going to keep working down because I want to show you something. 3 times... No, there's nothing there. Okay, 3 doesn't work. What about 4? 4 times 25. That works. What about 5? You can see that I'm being systematic here. I'm testing 1, I'm testing 2, I'm testing 3, I'm testing 4, I'm testing 5. 5 times 20. Yes, that works. 6 times, no. I also know 6 doesn't work because 3 doesn't work. 7. What about 7? No, those don't work either. So 3, 6, and 7 don't work. What about 8? 8 doesn't work either. No. 9. No, 9 doesn't work. 10. 10 is special. 10 times 10. Alright, if I keep working down, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 is the first next number that's going to work. 20 times 5. But wait, I've already tested 20 times 5 because 20 and 5 and 5 times 20 are the same thing. You don't have to test every single number from 1 to 100. You only have to test up to the square or the square root of the number that you're testing. So just testing up to here would be plenty to figure out whether something was prime or not. So if I wanted to know if 97 was prime, how many numbers would I have to test? Alright, so what's the square root of 97? Now I don't have a calculator on me, but I do know that the square root of 81 is equal to 9. 9 times 9 is 81. And I do know that the square root of 100 is equal to 10. That means that the square root of 97 would be somewhere between 9 and 10. I don't know. It's probably 9.9 or something. But what that means is that I only have to test up to the number 10. That's all I have to test. Actually, I only have to test up to the number 9. Alright, so 1 times 97, that works, and that we so far know that's always going to work, right? What about 2? Well, obviously 2 is not going to work because that's an odd number. 3. Now, to test for whether it's divisible by 3, I can just do 9 plus 7, which is 16. 16 isn't divisible by 3, which means that 97 won't be divisible by 3 either. Okay. What about 4? Again, it's not even. 5, it doesn't end in a 0 or a 5, so that doesn't work. 6, it wasn't divisible by 3, so it won't be divisible by 6. 7, I don't have a good test for 7, but I will test it out. No, it doesn't work. 8, it wasn't divisible by 4, wasn't divisible by 2. It can't be divisible by 8, obviously. 9, we can do a similar test that we did for our 3 here. And by that, I mean that, well, let's think about 9. 9 plus 7 is 16. 16 isn't divisible by 9, so 97 isn't divisible by 9 either. I've tested everything systematically, and that means, therefore, and I can use these 3 dots to mean therefore 97 is prime. And you might be asking yourself, do you seriously have to test all those numbers? Like, I know that at least we don't have to test, like, 1 to 97. At least we only have to test up to the square root of 97. Yes, you absolutely do. Now, this is something that gets used in the computer world a lot. We benchmark computers against how long it takes them to test whether a number is prime or not. Now, obviously, testing that for a computer would be instant, but imagine testing a number that was 1,000 digits long. Computers, that's how we benchmark how fast their processors are, doing something like that.